In this video, we're going to look at several different ways of representing one-dimensional arrays using our assembler directives. Now, what do we mean by a one-dimensional array? Well, put simply, it is a block of information. And we may want to work with a block of information as opposed to a single element. So we could take the block of information and we can act on each of the elements individually within that block of information. So how do we define an array? Well, there's really two things we need to know. We need to know the starting position of the array. So this is the position of the very first element of the array in memory. And we're going to give that starting position a name. And that name is the name of the array. Now, the second thing we need to know is the length of the array. And we're going to have to save that information somewhere within our code. So you can see here I've got a memory block here. And this memory block has got 10 elements. So let's say this constitutes our array. Then the two pieces of information are the starting address. So let's say this starts off at address in hex, we'll call it 0x8100. And it's going to contain our first element. So our first element could be anything. So just let's say our first element is the number 10. Now this memory location, which contains the first element of our array, this is then given the array name. So we could just simply call that array underscore name. So this is the first element that we need, which is the name of the array, and it's just associated with the memory location of the first element. Now the next thing we need is the length of the array. So in this instance here, the length of the array is 10. So we're going to have to store that array length somewhere within our code. So we could call this array and we could call it underscore length, and that is equal to the value of 10. So there's 10 memory locations here. So these two items that we have generated, the array name and the array length, are the two things that we need in order to define our array. The array name is simply the memory location of the first element, and the array length is the number of elements within the array. So as I said at the beginning of the video, we're going to look at several different ways of generating and manipulating our arrays using our directives. So we have three directives there at the moment. We have our EQU, our DC and our DS. So we're going to look at the simplest form here for the moment, which is using the EQU. Now in this example, we're going to generate an array, and it's going to contain the elements 0, 1, 2, 3, 4, 5, 6, 8 and 9. So these are going to be in the memory location that starts off at 0x8100, and we're going to have an array name and array length. So let's go ahead and we'll do that now. So here is our little snippet of code which we're going to use in order to generate our one-dimensional array. Now we're going to look at several different ways of manipulating our arrays using our different directives. So we have our DC directive, our DS directive and our EQU directive. So in this example here, we'll just use the EQU directive. But when we generate more complicated code, we will be using potentially all three of them. But to start off with, we will keep it simple and we will just use this one directive. So we said that in order to define our array, we're going to have an array name. So the array name here is the EQU1, and the array name is simply called array. And the array name is associated with the first location of the array. So the first address of the array is going to be at 0 × 8100. The other thing we needed is the array length. So we've got array length here, and it's a value of 10. Now we're going to put the array length into register R1. So this array length is going to contain the value 10. We then move on to the beginning of the code. Now the first element of the code is the one that is most interesting. So in this command here, we're going to store the contents of register R0 in this memory location here, which is array plus the index register. So the register R0 here is going to contain our numbers. So it's going to start off with the number 0, and then we have to generate the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have to increment this register after each iteration of this code in order to generate our numbers. And register R1 is going to contain the length of the code. So we're going to have to decrement the value in this register because it's going to count down from 10, 9, 8, 7, 6, and when it gets to 0, we'll know that this one here will have counted all the way up to 9. So we will have generated all of the numbers that we require. So what we have here is a form of addressing mode which we've seen previously called indexed. So we're going to put the value R0 in a memory location, but this memory location is going to change. We're going to add 1 onto it each time we go through the loop. So this allows us to put the numbers 0 in one memory location, and then the 1 in the next, and then 2, 3, 4, 5, 6, 7, 8 and 9. So we store initially the value of 0 in the memory location given by array. So array is the base address of our array. So we start off at 0 × 8100 as the base address, and then we add on the index. So the index in this case here is just a value of 1. So it means that we're going to have to increase this index register by a value of 1 each time. So we can see here we go through the process of putting the first value 0 into the memory location 8100. We then increase this index register so that the next time it comes round it's going to put the next value in 8101. We increment R0 so that the next time it comes round it's going to put the number 1 in as opposed to the number 0, and we decrement R1, so we decrement the counter here, which really tells us that we've now went through one iteration. So this is counting the number of iterations that we go through. So we have to compare the value in R1 with the number 0. So whenever R1 is equal to 0, we'll know we've gone through 10 iterations and we will have filled up the array. And we can jump to the end if this here is equals, and it just ends the code. Now if this value isn't equal, then it jumps back to the beginning, and again it goes round and it picks up the next instructions from the loop. So that's relatively straightforward. Let's go ahead and we'll see it actually working. Now I have gone ahead and assembled the code and I have loaded it into the RAM. So you can have a look at the code within the resources section and you can do all this for yourself. Now let's run through it, and I've slowed it down a little bit so we can see it actually working. So we're going to put the value 10 in our register R1, and this contains the value 0 and then 1, and as this counts up to 2, this will count down. So if we head into the actual RAM, you'll see that the contents here of the RAM, if you look closely, we have a 3 here, then there's a 4, the next one will be 5, and then 6. So it's counting along and it's putting all of the values in. So you can see here, if you jump through, you can see it generating all of the necessary commands, and you can see it running through. So let's go to the top level again, and you can see it's just finished there. The value for register R0 has gone up to the value 10, register R1 has gone to 0. So it's now finished, and you can see the little red light has come on, and we should have all of the values 0 to 9 within our array. So our array starts at 8100, and it takes these 10 elements all the way up to 9. So that's us seen a simple way of generating a one-dimensional array using our EQU directives. So let's continue in the next video, and we'll look at different ways of generating our arrays and manipulating them.